Our last two sections in our prerequisite review are solving systems. There's actually three methods to solve systems. One is graphing, which isn't very exact, especially if the solutions aren't nice whole numbers. If they're fractions or decimals, it's kind of hard to name the solution from a graph. The two exact methods are algebraic methods. One's called the substitution method, and the other one is called the addition or elimination method. So those will be our last two sections. So a system of linear equations means two or more linear equations. So you can see here we have two. This one's already in the form y equals mx plus b. This one's not, which they don't both have to be. But you can see that there's no exponents. So because there are no exponents, we call those linear equations. When you move into Math 150, the next class, you'll have circles that have squares, and you'll have parabolas that have squares, and you'll be plugging into equations that aren't just linear equations, but you'll use the same methods. So that's why I thought these two sections were really important, especially if you haven't taken 091, because you're going to need to know them for the next class. So the substitution method for solving a system, and remember, a system is just two or more equations, and what you're finding is where those two equations cross. So you're looking for the point of intersection. So solving means, let's just write that down, find the point of intersection. And once you move into like parabolas crossing with lines, for instance, if you have a parabola and a line's crossing it, you're going to get sometimes two solutions. Or if you have a circle and a parabola, you could have four solutions. With lines, we're either going to have one solution, means they're crossing. If they're parallel, we're not going to have any solutions. And then some of them are going to be a line lying right on top of another line, and we'll have infinite solutions. So when we're doing linear equations, we can have zero solutions. Well, let's finish writing this. So find the point of intersection. The reason I got on the tangent is because now we're just finding a point or points if the lines lie on top of each other. But once we move to the higher levels, the x squareds and y squareds, then we could have several points. So finding the point or points of intersection, that's what solve means. So because of that definition, that means all of our answers need to be in ordered pair, because they're the point where the two lines cross if we were to put them on the same coordinate plane. So we graph the two lines, we'd find their point of intersection. This is doing the same thing, but without graphing. So my point is, all your answers should be written as an ordered pair, a point, when you're finished. So you need to find your x and find your y. And like I said, you could have zero solutions if the lines are parallel. You could have one solution if the lines just cross. Or you could have infinite solutions, which means one line lies right on top of the other line. So there's one line, and then you go to draw the second line, and it's right on top of it. So that would be a case of infinite solutions. So those are the different solutions we'll have. Zero solutions if the lines are parallel. And remember, parallel lines have the same slope. One solution if they're just regular intersecting lines, and the solution will be that point right there. Or infinite solutions if the lines lie on top of each other. So those are the three scenarios we'll see throughout these notes. So solving by the substitution method, and let's highlight this because this is important. Isolate one of the variables. So that's the key first step. You don't do that in the next method. So I either need to get an x or a y alone. That's step one. And I always want to pick the variable with a 1 in front of it. That's the variable I want to get alone. So pick the variable with a 1 in front. It's called a coefficient of 1, but I'll just write it in layman's terms, so a 1 in front. So pick 1x to get alone or 1y to get alone. Don't try to get 3x alone because then you're going to have fractions. So we always pick the variable with a 1 in front of it. Then once we solve for that variable, we substitute it into the other equation and solve that resulting equation. Then once we get the solution, we substitute it back in to find the second variable. And then, like I said, all of our answers should be written as a point because that's what we're finding, the point of intersection. And we can check by plugging into both equations. So if you just plug into one, that's just going to show that it's a point on one line. You have to plug into both equations in order for it to be a valid check. Okay, so let's practice those steps here. I'm going to make the screen a little smaller so that we can see the steps. So solve the system using the substitution method, and on the test they're probably going to tell you what method to use too. And remember, I have you turn your work in, so make sure you use the method they ask for. If the system does not have one solution, state the number of solutions, so it's either going to be 0 or infinite, and whether the system is inconsistent. This is inconsistent when we have 0 solutions, or dependent is when one line depends on the other line and they graph right on top of each other. Okay, so they want to know how many solutions and whether the system is inconsistent or dependent if it does not have exactly one solution. Okay, so everybody ready? So step 1, isolate one of the variables. Well, look at this. See how y is already isolated? So I always tell students box that because you're going to come back to that one later. So I isolated one of the variables. The y is all by itself. It was already done for me. Step 2, substitute that into the other equation. So this is where you have to be careful. So this says y equals 13 minus 3x. What that means is y is the same thing as 13 minus 3x. So if it's the same thing, I can go into the other equation, take out the y, and put what it's equal to in, 13 minus 3x. And I always have students stop me at this point in the class and they go, well, why would you do that? Well, now I'm going to have all x's, and I know how to solve an equation that has all x's. I don't know how to solve an equation that has x and y. So by taking the y out, plugging what it's equal to in its place, now I'm going to have all x's. Because this is a quantity, it does need to be in parentheses. So this is what my next step will look like. 9, take the y out, put what it's equal to in its place, 13 minus 3x, and then write the rest of the problem just like you see it, plus 2x equals negative 8. Okay, so solve for the variable with a 1 in front. That was already done. Plug that in for the variable on the other equation. So take y out, plug what it's equal to in, and now we solve the resulting equation. Okay, so I'm going to make it big again so you can see this work. So first we have to use our methods from our very first day of class when we learned to solve. So we have to distribute. So 9 times 13 is 117 minus 27x plus 2x equals negative 8. So the first thing we learned was to get rid of the parentheses to distribute. Second thing we learned was if there's like terms, be sure and combine them. So this is going to be 117, negative 27 plus 2 is negative 25x equals negative 8. Now we need to work on getting x alone, so we need this over with the other constant. It's a positive right now, so we do the opposite, subtract 117. And 117 minus 117, 0, so we get negative 25x equals, and I believe that's negative 125, but let's just check. So negative 8 minus 117. Negative 8 minus 117 is negative 125. And then to find x, we divide both sides. We do the opposite of times negative 25, which is divide by negative 25. And we get x equals, so we have negative 125 already in the calculator. Then we just hit divided by negative 25, and we get 5. But remember, we are looking for the point of intersection. I only have a piece of that. I have half of it. I need to find y, and that's why we box this equation, because then we go, oh, I go back in and I plug my 5 in. So this is kind of like a double substitution. First you substitute 13 minus 3x in there, and then after you find your first variable, you plug that in. So to find y, it's going to be 13 minus 3 times 5. So 13 minus 15 is going to give us negative 2. So we have 5, negative 2 as our solution. So that's the point where the two lines cross. So I'm going to go ahead and solve the next one, and then I'm going to show you how to do a check. We won't check all of them because I don't want to bore you, but I do want you to know how to check, because these are big money problems. You know, usually teachers will make them worth 5, 6, 8 points. So you want to be able to walk away and go, yes, I got that right. So let's go ahead and solve 2 first, and then I'll show you a check. Okay, same directions. So we had one solution on this, which means the lines were crossing one point of intersection. So on this next one, notice that we don't have a variable alone. So remember how I said pick the variable that has a 1 in front? Well, I look at my choices here, and there's only one variable that has a 1 in front. That means I want to get that x all by itself. So if I want to get that x all by itself, I have to do the opposite to move everything else over. So subtract 5y, subtract 5y. So look what I have. My variable with a 1 in front is now all alone. And notice I did not put that 5y under the 8. They can't be added or subtracted because they're not like terms. And we box it, because remember, we come back to that on the last step. So once I get the variable with the 1 in front of it alone, then I go into the other equation. If you go back into itself, it'll just zero it out. You always have to go into the other equation. This says x is the same thing as 8 minus 5y. So take your x out and plug in what it's equal to, 8 minus 5y, and because it's 2 terms, it does need to be in parentheses. So my new equation is going to be 2 parentheses 8 minus 5y plus 6y equals 16. So solving that, see how it's all y's now? So now I can solve it. I don't know how to solve this. It has an x and a y, but once it's all y's, I can. So I get 16 minus 10y plus 6y equals 16. Here's some like terms here. So I get 16 minus 4y equals 16. and we'll pick up from there on the next video because I see we're running out of time.